Okay, now we're going to look at some slightly more interesting graphs. Okay, so what we're going to do is we're going to put this, we're going to put these things in decimals, right? And we're going to graph the function. Now, before we do that, I want to just kind of talk about this. This is still my b. My b is still this number, even though there's something multiplying by it now. This is still b, right? That's still b. That's my form, right? And b is greater than 1. Right? Because it's 2. So because of that, I know that I should get something in some way that looks like that, right? And going to kind of go off, and then we'll have some kind of asymptote somewhere, you know, that's not, it won't be dashed or sorry, running at an angle like that. But we'll have an asymptote of some kind, and then we'll have something that's kind of going up that way. All right, so we got 3 times 2 to the x plus 1. So let's take a trip to Desmos. All right. So I'm going to type in y equals, and now I'm going to try and move this over. The Desmos won't completely spaz out when I do it. All right. And when I do this, I'm going to use my 2 to the x power. So I'm going to use this a to the b thing, right? So I'm going to write in 3, and then I'm going to put in times, right? And so I don't really have dots on this, so I'm going to use this, right? I'll use a parentheses 2, and then I want to write 2 to the x. So you hit your b, and then put in your x, right? And then Desmos is like, oh, yeah, I know what you're doing. I've seen these before, right? And then we put that in, and then plus 1. Right. So really quick, I'm going to get rid of that plus 1 once, and I want you to watch what happens. So we get rid of the plus 1, and my asymptote is still at 0. But as soon as I put in that plus 1, look what happens. It changes my asymptote, right? And then, you know, if I change that to plus 3, right, it moves it up to 3. So that plus number on the outside is always going to be, that's what's great about these. That's my asymptote. And they're telling you basically right there in a way that that's your asymptote, right? So we've got something here, and it looks like it starts to go up, right? And it crosses. And instead of crossing, like if this were my asymptote, right, which it is right here, it's normally it goes up to 1. Right? It goes up 1 above where your asymptote is when it hits 0. This one goes up 1, 2, 3 units above that. Well, that's related to this right here, this 3. This is telling me it's growing 3 times as big, right? And then so then when you have 2 to the 1 power, which is 2, it's going to triple that, so it makes it 6. So it's, you know, way up there, except we raised it 1, so it's 7, right? So these numbers actually, you know, kind of mean something here, right? So when we graph this, right, when we come back and we graph this, right, I know that first of all my asymptote is going to be at 1. So I'm going to take this and I'm going to draw a line straight across. Okay, that's my asymptote, and I'll say y equals 1, and that is my asymptote. And I also know that if this is 1, this will be 2, this will be 3, this will be 4, 5, 6, 7, right? And we'll go 1, 2, 3. We'll put in some simple numbers here like this. All right, so if I put in 0, right, remember that it put me 3 units above it because 2 to the 0 is 1. 1 times 3 is 3. 3 plus 1 is 4. So we go 1, 2, 3, 4. So it's up here. And then if I put in 1, right, 2 to the 1 power is 2. 2 times 3 is 6 plus 1. So that's 7. So 1. So you got 1, 2, 3, 4, 5, 6, 7. So that puts it all the way up here, right? And so then basically we know that we're going to have something that's sort of growing like this. It comes down, and then it's going to start to taper off and go that way, right? And so this is my exponential function. And so here are the things that changed about it. Your asymptote went up 1, and then instead of crossing at 0, 1, or even just 1 above the asymptote, it is now crossing at 3 above the asymptote because of that, right? So we have that point 0, 4. Okay, so that's kind of how these work. The domain, it's still all real numbers. Still can put anything in these, right? And now for your range, my range follows my asymptote. So if my asymptote is at 1, that means that it's never going to be below 1 or even touch 1. So y is greater than or equal to 1. Okay, and so that's how this one works. So let's take a look at this next one here. All right, so we got 1/4 to the x minus 2 minus 3. Whew, all right, well, I bet this minus 3 means that my asymptote's going to be down here at -3. We'll see if that's right, but let's the rest of it is going to be interesting. So let's go have some fun here. So we go, let's toggle this off, put this on. We've got y is equal to, and I'm going to put the in 1/4. Sorry, that did not work out. Okay, and then we're going to close that off. And then for my exponent, right, we're going to put in x minus 2. Sorry, x. I want it to stay up there, not keep moving that way. All right, well, let's try this. X minus 2. There we go. All right, and so you see that? Now we got that -3 that we got to put in. And sure enough, that's what happened is we moved that asymptote down, and this thing drops way faster than it did before, and it flattens out way quicker too, right? It doesn't take its time so much. And so you can see if your asymptote's here, right, and it's starting to go up 1/4, right? So if this -2 to me, that probably represents that, you know, if we look at what does it have to be for this to be 0, right? So for this to be 0, right, it would have to, x would have to be 2, right? So at 2, right, is where this thing should be 0. And so that would be kind of my 0. And if my asymptote's at 3, it would go 1 up. So it does kind of follow sort of that pattern of what we're used to seeing, right? So this kind of tells you it's sort of like it's shifting your y-axis 2 units this way, right? This -3 means it's shifting your asymptote down, and then the 1/4 is just the degree at which it kind of, you know, it shrinks, right? So let's take a look at this, and let's do this. All right, so I know that I'm going to have, let's see, we'll go 1, 2, 3, go 1, 2, 3, 1, 2, 3, 4. We'll just make a few of these. 3, 4. So I'm now going to make my asymptote. Right, so this is the line y equals -3. I know that it's going to get close to that, but it's never going to touch that. And I know that at 2, that was where it was 1 above here. So this was at the point, this was the point 2, -2, right? And then at 1, it makes this -1, right? Because 1 minus 2 is -1, right? And so 1/4 to the -1 power is basically 4 to the 1 power. 4 minus 3 is 1, right? And so that puts it like right here. And so you can see how quickly this thing grows, right? And then if I put 0 in, 0, that makes it 4 squared, right? Because 0 minus 2 is -2. 1/4 to the -2 power is 4 to the 2 power. So you have 16 minus 3, which is 13. So that's way up here. So this thing just drops in a hurry, right? And it comes down, and then it flattens out really quickly. And then it just kind of goes this way. All right, so that is the story of this one, right? There's a couple points. You can put values in, right? I'll move this up here to -2 just so you can kind of see it, but they kind of follow the same logic and the sort of the same patterns, right? And so so yeah, my domain is going to be all real numbers again. So go x, it's all real numbers, and then your domain, your range, sorry, is going to be anything that is greater than my asymptote, right? So it's going to be y is greater than -3. And there you go. So fun with decimals, fun with graphing. Enjoy these. They're weird, but they're predictable. So I think you do a couple of these, you'd be like, oh, I got this. And nothing like the ones you were doing. So you can totally do this. All right. Thanks for watching.